Welcome back. And I think today we are going to talk about something very important, which we see in all the electronic devices, ICs, everything, right? And we saw a highlight of this in the last video when we were talking about DRAM and the building block inside the DRAM, basically, which is a transistor and capacitor, right? And so today we are going to look at something called leakage, that where what is this leakage, right? And what happens due to this leakage. So let's just talk about first what happens in the leakage. So you've seen that you have a mobile phone, right? And your mobile phone, if you even keep it off, let's say you charge the mobile phone, right? It's fully charged and you keep it off, you are not operating. There is no operation, right? So you're not operating, no operation, but still you see that your mobile becomes like there is no battery, right? No battery means it's basically no charge on the battery, right? That is the technical meaning of that no charge. The battery. So battery has become fully discharged. And why that happened, even if you are not operating? That is the question you will see, right? So basically, the analogy of that is if you think that you have a full tank, you have filled the water tank, right? You have water tank and you connect it to different taps and everything, right? Which we were talking about, one of the taps. So this is your tap which you have, right? This is connected to this water tap, right? This is a control knob. So you see that if you connect this to the tank and if the control knob is very good, like which you see typically, there is nothing coming out of this, right? There's no drop which is there. So when there is no drop, you will see that water level will typically be whatever you have left with. But suppose this happens a lot sometimes that you see that the your tap has become little old and then the control knob is not very good to control and there are still some droplets coming, right? So some droplets which are coming out of this, and due to these droplets which come out, you see your water level is going down, and that is what you have typically seen, that you didn't properly close the tap, and then you see your whole water tank and then you're like, oh yeah, the tank has gone empty. And actually that is, if you see at a very abstract level, that is what is happening to your mobile phone, that there are some taps, right? So that means there are some control devices which are there inside this mobile phone. And if the control, that means there is a leakage which is happening due in the control devices. There is a leaking in the control device, it would lead to discharging of the battery, right? So that is, let me talk about then again. And before this, I will say, if you have not watched the video of DRAM, where we talked about the building block inside the DRAM, maybe look at it so that you can better get the context of what we are talking about. But still, I think this is the circuit which we said that this is the workhorse in a DRAM, where you have a transistor which is kind of telling you which bit, because you have so many bits, which bit I should control. So there's a control signal which is coming here, which we know as the word line, right? This is what. There's a signal here which is basically what do I want to store? What am I reading? Am I writing? What is that I want to do? Am I writing one or so? This is your write line, or which we know as the bit line. Right? Write is not correct because there are, as we discussed, there are two operations, reading and write. So let's call it bit line, where you're giving the data what you need to write, or you are reading the data there, right? It's the bit line. So now, if you see these two constructs, or these two components, you see the whenever, let's say, if you are writing one, which is, let's say, for example, you apply 5 volt, 5 volt comes here, you wrote to the capacitor, the current is passing, and you have written 5 volt, right? This has happened in the when you are writing 5 volt. Now, what happens is, after that you have written, this guy goes to 0 volt, right? That is what happens. Why? Because now you want to store it, right? This is, you are not writing anymore. And this has, sorry, this has also gone from 5 to 0, right? Because there's nothing, so that whatever the initial state of this is, it would remain. It could go to some other voltage also. So typically, they typically use, let's say, some immediate intermediate voltage here, right? So there are different schemes one could design how to put the pre-charge or the charge when it is not operating. So let's say, for example, it is 2.5 volt. It could be any reference voltage where when you are not writing, right? So now when 0 volt is there, here is there's 2.45 volt. Now what is going to happen? So one thing is, when you say very surely that at 0 volt, the current, which is, let's say, this is I, which we are talking about, I is close to 0. Now now we are going to look at what is this close to 0, because you are not saying it is I is equal to 0. Sorry, it's because it is, if it was I equal to 0, then you're like, oh, there is no leakage, it means there is nothing happening. But in reality, because we know that in these transistors there is a leakage which is happening, and we will talk about the device characteristics and something in another video. This region, just if you know, you have heard somewhere in transistor, this is the region which is called subthreshold region, or where below the threshold voltage, which we talked about also for the transistor, that this is flowing, right? This current is flowing, which is what we term as the leakage, right? This is my I leakage. Now, what is the typical value of this current? This may change based on what is the size of the transistor. There are multiple things which could, or the threshold voltage of the transistor, or the technology of the transistor, right? Typically, let's say if the range of this is somewhere in nanoamp, right? So, and we typically describe this in nanoamp, for example, per micron. Micron means it's the width of the transistor. So if I simplify it, let's say, for if you are making a transistor of, let's say, 50 nanometer here, right? Because as we discussed, everything is becoming very, very small so that you can fit in. So then you can calculate what is the I leakage you are getting, which is 100 nanoampere, right, into your 50 into 10 power minus 3. So that would come to, so this will be 5,000, so 5 nano, right? So you see that 5 nanoampere is flowing still through your transistor. Oh, now if I say, and this becomes now a circuit where you have some kind of leakage which is happening, right? So we are not directly going to circuit, but we can have a look at this, what is going to happen. This node is, let's say, 2.5 volt. This is the I leakage which you are having, right? And this was 5 nanoampere. Now the question, and this you have to choose what is the capacitor initially, how many femtofarads or so it would be, right? So let's say this was around 1 picofarad, for example, right? So then in that case, you would see that in how much time, and this is a question of now RC, time constant, that you would see in how much time you would see that this capacitor will discharge, or this would come to 2.5 volt. And that is where you have lost charge in the capacitor or the state of the capacitor, right? And that is what would mean that your mobile now, and your battery is, because it is this charge is coming, or this current is still drawn by the from the battery, right? Because these transistors, everything is connected to battery, so it is still like these voltages, whatever this voltage is coming from battery, right? So when this is coming from battery, that means there is a current which is drawn to the from the battery, right? So when it is drawn from the battery, then you see that, oh yeah, I mean, this is a problem which is happening. That means my devices are, or my transistors, because they are leaking, this thing will discharge. The state will go to, let's say, 2.5 volt, because this is 2.5 volt. Here, if it was 0, then it would try to go to 0, right? The capacitor, because that is the equalization which would happen, right? When it is equalized, both become 2.5. There is I leakage, right? Becomes 0. That is the property of the transistor. When two levels are same, that means there is no current flow, right? That is what we talked about for transistor control. So now we see that this is a big problem, right? This leakage is a big problem in all the electronic devices or systems I'm building. If there are chips which will have transistors, these transistors will leak. The only thing now becomes is how much they will leak and how you can deal with it, right? Because they are going to leak if it is connected to battery. There is a path for the current which is flowing through the battery, it would, right? And that is why you see typically when you are, let's say, putting a toy or something which has electronics inside, you typically what you do is you take out the battery from that, because you know that your battery will go, it would go discharge, right? It would become discharge after some time. In mobile, we cannot do that, right? Earlier, we used to do that also in the when the mobiles were very old in Nokia. We used to take out nicely the battery, but now the battery is integrated, and then you have to open. It's not so convenient to take out the battery. Wherever you can take out the battery from the electronic system, that is the best way, because then you can, this leakage would not be there, because there is no supply voltage which is there, right? So when there is nothing there to supply, that means everything has shut off, right? Then basically that is the best. Then you would not see that you have a problem. But the problem there is that if you do that, right, that you don't provide anything, then the question is, what is this transistor will stop working, right? Stop working means there is no current flowing through the transistor, right? When it is off, in a sense that the both VDS is same, right? And the transistor is just off in that condition. So now for the leakage, if we talk more about the leakage, that yeah, so this is something you can calculate, and that is what we talked about. There is something called refresh circuitry in DRAMs, which basically put this charge back, right? Because there is a leakage happening. And now is this leakage, how do we really, or what are the different ways one can see this leakage, right? So then, yeah, so whatever you are computing, if with the chips, you would see that this leakage, when you are not operating, it is always going to be there, right? But how much you can minimize is depends on how you can tune this leakage, right? Or there are some ways that you can reduce this leakage also, right? Which is the circuit level techniques one can use. So for now, I think that is, I hope this gives you a very good idea that this leakage, how it can affect different devices, as different chips and everything, right? And this is a big problem. And this, the one of the important thing I think one needs to also understand, is this leakage a function of temperature, right? So this leakage, is it a function of temperature? Because temperature is also very important variable, and this we will talk about when we will talk about semiconductors. What is a semiconductor, right? So as of now, we have all going from the system understanding to the device, and we are talking about MOSFET anyway. Or so now the next would be, we would talk about the different construction of the MOSFET itself, right? So that means the question comes, is the leakage function of temperature? And if you understand semiconductor, you will say yes, big yes, right? Because in semiconductor, when you see the things which we are having, or the physical quantities or the properties of the semiconductor, are very much related to temperature. Or it's a very strong function of temperature, I should say, right? So that means what you see is, if you have a chip and you are operating that chip and you are really having a problem with leakage, right? Where would you put it? You will put it in a fridge, right? There is a different thing that in a fridge, all these devices will be able to operate so fast or not. But definitely, you would put, it's basically like your brain, right? If you are putting, as we were talking about in heat, it slows down, and also your energy is going away quite fast. While in a colder temperature, you see that your energy is conserved, right? And your thing, sorry, your things will become slowed down, right? In the colder temperature, sorry. In heat, so extreme is bad, right? Both extreme is bad. And so similar thing happened to a transistor also, that in a transistor, if you are operating at, let's say, room temperature, which is 298 Kelvin, versus when you are operating it at 30 Kelvin, right? What do you think happened to the leakage, right? That is the question I'm asking. And I think you should ask yourself and convince yourself what is happening. And whatever questions you have, put in the comment so that we can address that, right? That is the whole point. It's learning together. So all of us want to be 1% better than what we were yesterday. That is the whole point of growth, right? We learn every day. We don't become an expert in a day, but we learn every day, and then we would be able to understand the different perspective which are there. And that is why this series, when we started, we said we are going to talk about all different things, right? We are just not going to talk about one thing and just talk about semiconductor physics or this or that. We are going to talk about everything which is there in the semiconductor, either that. And whenever there is more expertise needed, we can have experts or expert lecture either recommended to you, or we can invite them to talk about that particular thing, right? So that is how we are going to go about. And happy learning and happy morning to all of you. Okay, with that, I will sign off. Thank you.